I'm very proud to present Team Hip Hip Array with their app Out of Orbit. Take it away. Thank you.
Hi everyone, my name is Daniel and I'm a part of Team Hip Hip Array. As you can see here, the team consists of myself, Richard, Joe, Matt and Rachel. Now, when we first came to discuss what we'd like to do for our project, there was a few things that were at the forefront of our mind. We wanted to make an app that was fun and entertaining. We wanted to make an app that was useful to people. And we also wanted to make an app that would make people's lives just a little bit easier. Now, there had been a few things, like when we brought all these ideas together, we came up with the idea of creating an educational app, something for children and parents alike. And we wanted something that could be used or designed with COVID in mind, that could help to educate and enrich children, but not just during these difficult times, but also when they're not at school, at home, because that can be just as important to children's education. So we came up with the app Out of Orbit. Now, this is aimed primarily at families and at parents who want to help enrich their kids' education. But we find it's entertaining for people of all ages, adults as well as children. Now, one of the things that we had really honed in on was how to keep people entertained, especially children. And we decided that augmented reality was the way forward, or AR. And so we thought that this would be the best way to make people receptive to the app, make it interesting for them. And we wanted to make sure that the AR would be important to the success of the app and to the success of the educational aims. Now, making this app interactive was our top priority. So I could pass you over to Rachel, and she will be able to take you through a demo of the app.
Hi, so I'll take you through how the app works. So we first come to the login screen, and we can either create a new account or log in as an existing user, as we're doing here, and that's managed by Firebase authentication. We then go to the mission preparation page, where we enter our name. We can choose a character from a number of different avatars. And because we're using augmented reality, users will need a marker, which looks like this. And we can click on this link and we'll get a PDF that we can either print out or display on another device. We then go to the mission details, which tells us what we need to do, which is to visit various planets, learn about them, and answer quiz questions to win badges. And you can see we've already won some, and some have yet to be won. To go to the planets, we can either click on these cards, or we can go to the menu and click Launch Mission. We can also reset our progress here if we want to, go back to mission prep to change our name or avatar, or sign out. When we launch the mission, we'll go straight to the 3D solar system model, and all our 3D models are sourced from NASA. The navigation bar at the bottom enables us to visit different planets. So here we've gone to Earth, and we can spin them and rotate them, zoom in, zoom out using our mouse or our touch screen on our phone. But we don't just have planets, we do have Pluto, and we've got other spacecraft such as the space station, you can see here. And if users do want to go into augmented reality, they can click on a guide. This just reminds them to print the marker and have it ready, gives them a bit of advice about what kind of background they need to put it on, and warns them that they'll need to give the app permission to use the camera. It also shows them how they'll use, they need to position the camera in relation to the marker. To go onto the AR view, there's a toggle button on the screen that they can use. And then we point our camera at the marker and the 3D image should appear in the camera view. And again, they can spin it around, they can zoom in and zoom out, but they can also walk around it and move the camera around the model to see it from all different angles. And we've used A-frame and AR.js to give custom behaviors that we wanted to our markers, to our 3D models. While we're on the ISS page, we can then go on the trivia for the ISS page. And again, we got all our facts from NASA. And this will help them answer the questions in the quiz later on. And on the space station page, they can also click on this link and it will show them where the ISS is right now. So it's currently orbiting over the Atlantic Ocean. And they can also watch a live feed from the ISS. And when we're ready, we can go on to the quiz. And each quiz has 10 questions, but you only need to get 7 right to get your badge. And if you don't get 7 right, you can do the quiz as many times as you want. You only have to answer the questions that you got wrong previously. When you do win a badge, you will get a notification that shows you your new badge. Hopefully they get a new badge. There we go. And then they can either go and see it straight away or they can continue the quiz if they haven't already. So we're continuing the quiz, and when we finally finish the quiz, we'll again get the option to either go and see the badge or to return to the planets. If we go back to mission control, we can scroll down to the ISS, and we see our new badge, and we see that we've got 8 out of 10 questions right. So I'll pass you over to Matt, who will talk about the technology that we used.
Thank you, Rachel. Hi. As you can see, our app is very heavy on the front-end side. So we use a database that's more back-end, that's easy to deploy and easy to use. So we went for Firebase. Our Firebase authentication system helped us to validate users' information like passwords and emails, and stored passwords securely on a Firebase server. And on our course, we were learning SQL databases, but we wanted to try something else. And also, the data set we had for facts and quizzes wasn't very complicated. It was quite simple. So we used Firebase database just to store all the information in the database, because it was also easy to seed that database. It was as simple as just importing JSON file with all relevant information. And I will now pass you to the front-end part to Joe, our AR and 3D wizard.
Thank you. Thank you, Matt. So when it comes to the front end, React is the framework that we have chosen. We also use A-frame and AR.js to build our 3D and AR experience, and Leaflets to display the live location of ISS, and Roman to quickly give some starting to our app. We have learned React in our course, so naturally we would have liked to play with React Native and build native mobile app. But in the end, we have decided to stick with React and make it a web app instead. A large part of this decision is because we want to utilize A-frame and AR.js in our products. Although the community is not that big and robust as some other major 3D frameworks, we saw some advantages in using A-frame. Firstly, because it is an entirely web-based technology, it is platform independent. You can run it on iOS or Android or Windows or any other OS or which have a modern browser. Also, A-frame performs decently well in low-end hardware. Therefore, with our app, parents can make use of some spare device in their home, such as an unused smartphone or an old laptop, to give their children an inspiring little journey into the outer space. And from a developer experience perspective, A-frame's decorative and composable nature is similar to React that we are very familiar with in our course, and that enable us to code the behavior of the 3D objects with a similar approach that we do in React. Just like how we make the 3D moving solar system that you see just now, we put the sun at the center, we put rotating rings components around it, and we popped the planet at the edge of each rings, and then put the props like rotation, velocity, the radius into each components, and it's done. And that was how we managed to start from zero knowledge with 3D AR and build an app with these features within a limited time span. And that pretty much concluded the test choice of our app. So now I would like to hand over to Richard to talk about some of the challenges that we have.
Brilliant, Joe. Thanks very much. So, Houston, we have a problem. I'm going to go through some of the challenges we faced in the development of our app. Luckily, we had a great team, so our challenges were fairly limited, but the challenges we did face, I think we overcame very well. So probably the biggest one was we used agile methodologies throughout our development of our app. However, we hadn't worked in such a large team during the course on Northcoders. We often worked in groups of 2. So obviously trying to manage quite a large group with different ideas for our app, different positives and negatives to their knowledge. It was difficult initially to try and hone all those skills into one app. But we did that through using, again, agile methods. So we had a scrum every morning, which was a stand-up, which I think we really refined. So after the first couple of days, I think it worked really well. So we limited it to a 10-minute meeting where we discussed what we'd done the previous day, any challenges we faced, and kind of an overview of what we were going to do. Once we'd finished that meeting, we set up a new meeting a bit later just to go into a bit more detail of exactly what we were going to do, the pairs we were going to pair up to, and what our plans were for the rest of the day. Any potential meetings we might have later on, so we often said, right, we'll meet up on Slack at 1 o'clock and just have a meeting to see how everyone was getting on. I think that gave us a great team, and any problems got ironed out pretty quickly, which led to developing the app that you can see today. Issues with some of the technology that we had. So AR.js, the documentation is still in development, so it's quite sparse a lot of the time, and it's a small community, so we had to do a lot of trial and error. So it was a lot of meetings between us, a lot of mob programming where we'd all jump in, we'd all chip in with ideas of what we could try to get it to work. And again, you can see today that eventually we got to a product that we were really happy with. On the other side of the spectrum, Firebase is a massive and extensive documentation, so it was often difficult to find exactly what we needed for our use case. Again, we had to use other sources, so if we didn't know it ourselves, we used Google, Stack Overflow, and we weren't afraid to ask people who knew more about it to help us out. And again, I think Matt did great work on finding that information and passing it on to the team, so we all knew where we stood with the back end. And with our APIs, we had a little bit of trouble with Netlify. So what was happening was the information we were getting for the live feed of the, sorry, not the live feed, but the live data of where the ISS was. We were having trouble because the API we were using wasn't a secure site. So when we tried to use that on Netlify, it was throwing up errors. So we needed to switch our API to a secure model. And I think what that really highlighted was the fact that we needed to ensure that security was at the forefront of our mind, no matter what we were doing in the app. And again, it just really highlighted that problem. So yeah, I mean, we're really happy with the app. We're really proud of it, and we just would ask that if anybody would like to check it out, we've put the link on this presentation, and we'd encourage anybody to give it a try. But if there's any questions, we'll happily take them now. Thank you.